All right, so today we're going to finish up 4.1. We have a few more topics out of this section that we didn't get to. So let's go ahead and jump in. First thing I want to talk about is arc length. Now, we actually addressed this yesterday in our notes, and we had this little formula down here that we talked about. In order to find how many radians, what the angle measurement in radians was, we took how long the arc was. That, remember, S was arc length. And we divided by how many radiuses we could fit on that arc. Now, what we're going to do is we're going to take that formula that we used yesterday, and we're going to actually rearrange that. And what I really want a formula for is arc length. So to get the S, which is arc length by itself, I'm just going to multiply both sides times R. So the arc length formula that we're going to use is S equals R theta. And it is worth noting what theta represents. That is your angle, but the only way the formula works is if it is in radian measurement, not degree measurement. Okay, so another way to think through this would be from our circumference formula that we talked about yesterday. Circumference is 2 pi r. All right, so ultimately, circumference is the distance all the way around. And so if you'll recall that the angle all the way around is 2 pi, because that's how much of the circle you're using when you find the circumference. But what if you were only looking for like halfway around? Well, then you wouldn't use 2 pi anymore. You would use 1 pi. Or if you were looking for just a quarter of it, instead of using 2 pi, we'd use, well, remember that this is half pi. And ultimately what this is right here is the angle that I am using to create the arc. So if I had some other arc, I'm going to just draw this and say, I want to know the length of this arc right here. Well, what I would do is I would find theta, the angle that's in here, multiply it by my radius, and that's going to tell you what that arc length is. Let's just try a basic problem here. It says find the measure of an arc of a circle. The radius is 40 centimeters. Central angle is 160 degrees. So I know I want to use the formula S equals R theta, and I know that I have the radius is 40. However, I can't use the 160 that they gave me because that's in degrees. So you have this little side note over here, and this is why yesterday's lesson was so important, that you know this stuff inside and out. So if you'll recall, to take a degree measurement, turn it into a radian, you're going to take it times pi over 180. Now, ultimately, this is 160 pi over 180, and I could try to reduce that. I could divide by 10. Let's see, these are both even numbers, so I could reduce by 2, and I end up with an 8 pi over 9. And that would be theta right there. So I'm going to come back over here to my formula, and let's fill in what we know. The radius is 40, and theta is now 8 pi over 9. Now, you'll have to pay attention to your directions. If they want you to leave it exact, then that's going to end up being 320 pi over 9, which is fine. Sometimes, though, we'll want to know what like a decimal approximation would be for that. So if you type that in, you would find that, that is approximately, we'll just go to the hundredths place. I'll say 111.70, and that is your arc length. So think about this. What would we label that if that's your arc length? Well, it's going to match whatever your length is measured for your radius. So right there is my arc length. Now, ultimately, this is the problem that I was looking forward to, because it's got a lot of info that we're going to need to know from yesterday's lesson and today's, tie it all together into one great big problem. So here's what we did. I went and found the distance between two cities on the earth. So we have New York and Valdivia. That's in Chile down here. Okay, so I want to know the distance from New York to Valdivia. Well, if I Google it, this is the number I get right here. It's that many miles. Now, if I'm not driving very far, I probably just do a straight line distance. But something that is this far of a distance, the fact that the curvature of the Earth actually would play a part in that distance. And so what I've done is I've taken this measurement right here, and I sort of like think of it like the Earth, and I rotated the Earth until that curve right there is on the edge of the Earth. So it would look like this. So I think this visual helps then. So here are my two cities, and I want to know the distance. Well, ultimately then, I'm just looking for an arc length. So I know that's my formula, S equals R theta. But I have a lot of work to do before I get to that. I guess the R is handed to me, so that's nice. I've got the R. It's the theta that I've got to work on. Theta is the angle created right here. Now, that angle is going to eventually come from the fact that I know the latitude of these two cities. Now, I circled those, but I should have also paid attention to the fact that that one is north of the equator. This one is south of the equator. So when they measure latitude, it does come from the equator. Equator is 0. So what this is saying is if I had the equator right here, that this is 40 degrees upward, 40 and some. This one is 39 degrees downward. So if I want to know the entire angle, well, I would just add those two angles together. So I'm going to take this angle plus this angle. Now, I'm going to say that, but ultimately, I'm not guaranteed every time that I would do that. What if your two cities were both in the, let's say they're both in the northern hemisphere, and that the latitude on this one we'll just say is 70, and the latitude on this one is, we'll just make it be 60. Now, these, and of course I'm simplifying this process, these would both be north, though. And so if I want to know what theta is, this angle right here, I wouldn't add these two together anymore. To find theta, I would subtract those two latitudes. So if you're in the same hemisphere, you'll end up subtracting. If you're in different hemispheres, you'll add. All right, now, if I want to add those two angles, I need to get them to be straight angles first. I want to get rid of my minutes and seconds. So step one, there's actually 4 steps to this. So write small and take good notes because I'm only doing one example. All right, so here it is. I'm going to take the 40 degrees, the 43 minutes, and the 50 seconds, and I'm going to convert it. If you'll recall to do that from yesterday, we did 40 plus, you take 43 and divide it by 60, plus 50 divided by 3,600. And just add it all up, and that's going to get you your angle measurement. All right, I just did that, and I got that to be 40.731. Okay, you're going to do the same thing with the other angle. You got 39 degrees, 49 minutes, 10 seconds. Use your conversion. It's going to be a 39. You're going to take your minutes over 60, seconds over 3,600. Type it in your calculator. I'm doing all the hard work for you today. And you end up with, I have a 39.819. Okay, step 2 is we had decided we were going to add, and I'm going to go ahead and in parentheses put or subtract, and maybe go ahead and make note of if in same hemisphere, just so that you have record of that somewhere. If you've already written it, then don't worry about it. If in same hemisphere. Okay, add or subtract. In this case, I'm going to add. So big plus sign, going to go boom, add these two together using full values as I do that. It actually does come out nice to an 80.55. Now, my label at this point is still in degrees. It's important to keep that because you start to lose track of what you just found. That's an angle measurement in degrees. Okay, Step 3, I can't use degrees to find arc length. I have to use radians. So I'm going to take my 80.55 number and I'm going to multiply it. And this is why yesterday was so important. To convert that to radians, I go times pi over 180. So I'm going to take that number that I have in my calculator and just multiply by pi. Your pi button is second caret. And I end up with 1.4, I'm going to go 406. Now, can you tell me what my label is on this? What did I just do? Changed it to radians. So that is the label. I'm now in radians. All right, final step. Step 4, I'm finally ready to go use my new arc length formula. So S is equal to my radius, which they told me was 3,956. You can see that just in the diagram right here. All right, and then I'm going to multiply it by theta, which is what I just found right here. I would like to use the full values, so I'm going to use that full value that I have in my calculator, and then just take it times the radius, 3,956. And my arc length ends up being 5,000 561.6. So dang close. Look, it would round up to a 62, but I wanted to write 61 because look, that's what we started with. We proved it. Now, do keep in mind that at that point you found your arc length and that unit would be in miles now. Final answer right there. Okay, a lot of stuff going on in that problem. It's a great one. You should start. It's probably on your test. All right. And then the other topic that we didn't get to yesterday is on linear and angular velocity. So there's two types of speed. There's an angular speed. You're maybe not as familiar with angular speed. Well, you probably are, but you don't think of it when you talk about speed. The speed is how fast something is spinning. That is angular speed. So typical units would be revolutions per second or RPMs. That's revolutions per minute. How fast is something spinning? All right, linear speed is probably the more common one that we think of, and that's just how far you're going in a straight line. Typical units would be miles per hour, feet per second, something like that, where you have a length that you're doing. All right, so the deal is that we try to connect these two ideas. So there's got to be some way to connect the linear concept to the angular. So that connection comes from thinking about, I just chose a bicycle instead of a car, but think about this bicycle. Let's say this dude pedals just enough that the tire rotates one time, just exactly one time. How far in a straight line would he gone at that point? And I'm not looking for an actual number because I have no numbers going here, but just a concept. If you travel just enough that this tire rotates once, then it's almost like you're unraveling it or unrolling it. And so the distance you would travel is the circumference of that circle or of that tire. So that right there is our connection. One revolution is going to be equal to your circumference. And that will connect the two ideas, the angular to the linear. Now your circumference, remember your formula for that is 2 pi r, or sometimes we just do pi d. It kind of depends on what they give you. If they give you the radius, we typically use this. If they give us the diameter, we'll do pi times d, whichever one's handier. All right, I got a couple examples I'm going to do here. One going from linear to angular speed and one going from angular to linear speed. All right, so to set this up, you're just going to do a whole bunch of conversions. And you maybe have done something like this if you've had chemistry. But what I'm going to do is I'm going to always start with the speed that was given to me. And in this example, they gave me the linear speed, 74 miles per hour. So I'm going to write that as a fraction, 74 miles in 1 hour. Now, Then I'm just going to multiply by a fraction. The only fraction I can multiply by without changing this problem is 1. It's got to be 1. But I can write 1 a lot of ways. Now I can see that I'm going to eventually want to be in minutes. So I need to get rid of hours and turn them into minutes. So since hours in the denominator, I'm going to put hours in the numerator. That way they will cancel. Now this fraction, remember, has to equal 1. So I'm going to say 1 hour is the same as 60 minutes. Those are equivalent, so that fraction equals 1. And I get to cancel out the hours. So now I'm in miles per minute. Okay, now the minutes are good, but I need to get into revolutions. So now I can do this in a lot of different ways. The order that I do these fractions doesn't matter. You just do what kind of makes sense to you. I can see that I'm going to have some issues because my diameter is measured in feet and I'm currently in miles. So I know that I'm going to want to turn these miles into feet at some point, but I also have to get revolutions involved at some point. All right, so for no particular reason, I think I'm going to get the miles turned into feet. So I'm going to multiply by, and since I'm trying to get rid of the miles and they're currently on the top, I'm going to put them on the bottom, which means feet are on the top. Do you know the conversion between miles and feet? 1 mile is the same as, 5,280 feet. If you didn't know that, you need to know that number. We'll use it a bunch, so you have it stick in your brain somehow. All right, so now miles are going to cancel out, and I'm in feet and minutes. I like that it's feet because I know I'm going to be using that diameter, but I've got to get rid of those too because my goal is to turn it into revolutions. So I'm ready to use my conversion up here, that 1 revolution is the same as the circumference. So since I want revolutions to be on top, because it's revolutions per minute, I'm going to put revolutions here. 1 revolution is the same as the circumference, 2 pi r. But since they did happen to give me the diameter, instead of writing 2 pi r, I'm just going to write pi d. So it's going to be pi times 2.7. Now, that 2.7 is in feet, which is going to be perfect because then that means those feet and those feet cancel. And if you look at what's left, the only units I have are revolutions over minutes, which is exactly what I want. So now I'm ready to do the calculation. You're going to just multiply all the numbers in the numerator straight across, multiply straight across, and then divide at the end. Let's go ahead and do that. I'll do the top, you do the bottom. Okay, I didn't wait for you. I went ahead and did it. All right, so those are my 2 numbers. When I divide those out, I get 767 point, I'm just going to go 1 decimal place, 0.7. And then my units are revolutions per minute. I'm just going to say RPM right there. All right, now let's try the other direction. In this one, they give you that Albert's truck tires, we've got a diameter. Here we go. It's given that the 630 revolutions per minute are how fast the tires are spinning, and we are looking for the speed of the truck in miles per hour. Always start with the speed they give you, regardless of what type it is. So in this case, it's 630 revolutions per 1 minute. Okay, so again, order is not important. I know I need to be in hours, so let's go ahead and get rid of the hours. Put minutes on top so that they'll cancel, hours on bottom. 1 hour is the same as 60 minutes. Then you can cancel the minutes. The other thing I need to do is get rid of the revolutions. So let's do our conversion. In this case, I want the revolutions to be on the bottom. So 1 revolution is the same as my circumference. They happen to give me diameter again, so I'm going to do pi times diameter. Now the diameter is measured in inches. All right, now that does get rid of revolutions, but I am currently in inches per hour and I want to be in miles per hour. So these inches have got to go. I'm going to first turn them into feet. So inches on the bottom, feet on the top. 1 foot, same as 12 inches. Inches cancel, and now I'm going to do that conversion to miles. So feet need to be on the bottom, so they'll cancel. Miles on top. 1 mile is the same as, do you remember? 5,280 feet. At that point, I've got the units I want. I am in miles per hour. So multiply straight across, and then divide. All right, this one, you're on your own. You have to do it. Get that calculator out. All right, I'm kind of impatient. Are you done yet? All right, the answer I got, final answer, after I divided everything out, is a 67 point, I'll go 5 miles per hour. All right, if that's not what you got, go check again on what you multiplied. Don't forget the pi, sometimes that gets missed in there. All right, that's all I've got for us today. Go give it a shot. Thanks for joining.